Get over here by Nirali. This is Nirali Shah. She was a student here.
Hello.
From, you graduated in 2009, right?
2009, yes.
So you're 2007 to 2009. All right, so she's been gone about 4 years now, right? So, and she spent the last 3 years, 3 years in 3.5 years in computer systems validation, right? Okay. So I had Nirali in a few classes, actually probably 3, right? 3 classes of mine, and very good student. Because look at where she is now.
Thank you.
Did you get the picture?
Very good professor.
Ah, there we go. I like that. I like that. All right, so she's going to talk a little bit about computer systems validation, in particular, how she got there, and we had a conversation. How did you get the job? I'm sure all of you guys are interested in that. How do you keep the jobs, and kind of what the job situation is out there, so to kind of get you jazzed up about taking classes and studying and doing homework and things like that. Okay, so with that, I'll turn it over to Nirali, and get that clip now.
Good evening, everybody, and thank you very much for being here. It is a very nice opportunity for me that whatever I have taken education here, that I can apply where I'm working right now. So first of all, I'll give a little introduction for myself. I have been graduated from here in 2009. I have done internship for AstraZeneca when I was here studying on CPT, and then I have started working for CSV from last 3.5 years, and currently I'm working for Nobel Biocare. It's a medical device company, and currently I'm working as a validation lead. So today I'm going I know that how many of you have taken a computer system validation class here at Stevens?
It's not offered.
What?
I was at least one.
I want to take, but it's not.
It's one person, right?
Only 2? Okay.
Make them take it.
Actually, today's presentation is purely on practical basis. What actually you face in the company where you are working as a CSV, a computer system validation specialist. So, in fact, it's my bad that I thought you all have taken the courses, so I have not included the basic theory, which you will be.
Professor covered computer system validation and introduction to validation basic history.
Yes, yes, okay. All right, so we are going to talk on basically on the practical approach of CSV. And as an optimistic approach, I want to start first that what are the opportunities of CSV. So you have some more interest in listening to the presentation. So, why there are more jobs? Let me tell you first, there are many jobs for validation. So, and you are competing in the market with the persons who might not have any background of validation. And the education given here at Stevens, I think is the best. You are given all the information, all the process which is being followed in the pharmaceutical companies or validation or medical device companies. You know everything. So you are already ahead of everybody in getting a job because you are studied here with best professors in the industry. So I think why CSV jobs are more than any validation job is because I know many validation jobs are there. But for CSV, because everything is getting automated in manufacturing. Computerized system, even in clinical trial evaluation, they are actually developing the software to put all the clinical trials to evaluate them, for the storage data, for everything. It's all automated tools. Even for testing, automated tools are getting into the practice. as we follow GMP, everything we use, which is used in a GMP environment, that has to be validated. So all these systems, all these softwares, customized, commercial off-the-shelf software, they all have to be validated. So I think that's why there are more jobs of computer system validation than any like process validation or equipment validation. Because, for example, equipment validation vendor will do their validation, and they will deliver all the IQ, OQ, PQ validation report, everything to the client. For process, generally process engineers are required for process validation, having that core knowledge of the process engineering. But for computer system validation, if you have a basic knowledge of computer, you can go ahead with that. So it's not like that tough area that some people think that, oh, this is computer system validation, I don't have a background, but it's not that tough. So be optimistic and learn the basics, whatever you learn in 541, I think, right? Computer system validation.
Yes.
Yeah, those basics are, see, I still remember. Those basics are very necessary. So if you know that why computer system validation is required, then you will have a more idea that what I'm doing and why I'm doing that. So these are all reasons or opportunities of the job for there are so many software as a medical device, class 2 or class 3, that are used in designing implants, in manufacturing of implants, knee implants, dental implants, breast implants. There are so many medical device implants for which the medical software is being used. Software in production of medical device, if that is used, and that has also to be validated. So let's start. I'll just give a brief introduction. What are the regulations for which we have to do a computer system validation? So to comply with 21 CFR Part 11, which is electronic signature and records, there are so many software which is complied with Part 11, but we have to validate that to store our documents, electronic signatures. So yeah, for Part 11 compliance. For Part 820.30 and 820.70, these are medical device quality standards, which requires all the softwares which are being used in production of medical device or as a medical device to be validated before it launches to the market. 21 CFR Part 211 and 606 is for biotechnology, all 606, and 211 is for pharmaceutical manufacturing. That all the systems and all the software or firmwares which are used in manufacturing, they have to be validated. ISOs are the international standards. If your medical device or if your product is being marketed or is being used by international markets out of US, you have to comply with ISO standards. So these are some ISO standards. 13485 is for the a quality standard for medical device. 14971 is a risk management standard for medical device. 62304 is a quality development of the software. Because there are so many softwares which are customized, being developed in-house, so you have to follow a software development life cycle for that. And this standards tells you about that. So these are the regulations for which our jobs are there. And to comply with these regulations, there are some guidelines. There are so many societies like ISPE, PDA reports. So they are giving you guidance how to comply with the regulations. So general principle of software validation, final guidance for industry. If you read that, you will have all idea what FDA is looking for to validate the system. Then ISPE guideline GAN 5. I think 640 also covers that, right? GAN 5. FDA guidance for industry, how to validate the Part 11 system. Any electronic document management system which is being used in the industry, they have to be validated. That electronic signatures are authentic, all records are authentic. So how to validate those systems? The guidance is there on FDA site, fda.gov. guidance developed by just some companies, if they have a very professional or very experienced directors or VPs of quality, they do their own articles and they do their own presentation. So they are also being followed by the company. So some companies have their own policies how to follow the validation. And PDA Technical Report 18, that also gives you the guidance how to validate the computer system. For clinical validation, for cleaning validation, it's 29 and 49. So let me go through 4 main categories and how much validation is required for all those categories. These categories are referred in GAM file. So there are so many complex, simple kind of computer systems, but you have to define that how much validation is required. If this is commercial off-the-shelf software, then maybe you just need a validation plan like QPQ and report. If it's customized, which requires the most extensive effort of validation, then you have to be involved from defining a user requirement to the end of to the deployment. I hope everybody knows deployment. Anybody who don't know deployment? What? Deployment basically means when software is being question?
No,
When software
in
is
the United States, deployment usually means that your son is being sent to Iraq or Afghanistan. Deployed. You're actually launching the software.
So once your software is validated, you deploy or you actually launch the software in process or in market. If it's a production use, then you launch the software in a production area, a production environment. If it's for the customer, then you launch in the market. So first is infrastructure software. There are some database servers, some middleware. These are called first infrastructure software, which are basically interfaces, and there is a minimum validation effort required in that, because you're just taking a flow that orders are going through that interface, or data is getting saved in the right manner. So minimum validation effort required. Non-configured software. There are so many software which are out in the market, configured, off the shelf, and generally vendor gives their assessment or validation documents for those systems. For example, Maximo. These are Maximo is used basically for the document storage. So these are validated system. You just buy it from the vendor. You just run a user acceptance test that it is right. You just qualify a software as a validated system at your site. Configurable software. There are many software which are developed by the vendor, but still you can configure something in that. For example, SAP. There are so many modules of SAP. So SAP is developed. You buy the system, but it has a capacity that you can change the code. You can configure something according to your need, according to the company's need. So they are configurable software. And the fourth is customized software, that the software is being developed in-house. There are developers in the company who are developing the software according to your need, and you have to validate the software. So for first two, I think minimum effort required. For third one, if it's configurable, then your focus should be what is configurable and how much is the risk of configurations. So your validation effort based on this. And the fourth one requires the most extensive validation effort. And I'm going to talk about that, customized software most, because everything else you have all the documents from vendor. So you just have to yeah.
I was going to wait till later, but are you seeing that more with the companies are willing to rely on the vendor's supplied validation documents? Because many companies years ago would buy that package but still repeat the whole thing. Are they starting to buy it and put it on the shelf and accept it, or they move on to these types of things, or are they doing something else?
basically it depends on the company how much trust they have on the vendor.
Right.
I have an experience that one of the vendor for our software, we knew that from the experience that he is not good in delivering, in actually testing. He will develop the documents, but we cannot trust that he has actually done that. This is true. So, I mean, for that particular vendor, we always used to repeat all the testing. So, generally, it depends on the case. Who are the vendors and what system you are getting from them.
Any quick thing you can say about how do you pick the vendors that you, if it's a new vendor you've never worked with, do you repeat everything? Or as you gain experience with them, you decide I can trust him?
Yeah.
So really you still do a significant amount of validation verification if it's a new supplier.
Yes. Okay. For the new supplier you do that, yes. So, software development lifecycle, there are 10 steps which comprise the entire cycle. First off is quality planning. Quality planning is generally established when company is starting. So quality policy is already established there. Second is you define a system requirement, that is called user requirement. Third, detailed software requirement, which is called a functional requirements. Fourth is software design specification, how the software look and feel of the software. Construction, then developers start developing the code according to the user requirement defined. Then it goes to the testing. The developers develop the code and test them. So that is testing. Then development is done. You do installation of the software, operation and support. In the installation, all validation is included in the installation. Operation and support, you maintain the system and then finally the system is retired after the. So this is the entire cycle of software development life cycle. So now in the entire cycle where validation specialist role starts and where it ends. So the role of validation specialist starts when user requirements are getting defined. Why? Because when business unit and developers, QA, risk assessment manager, they will be sitting together and we have to be involved because we are the one who will tell that this user requirement is possible to verify or not. Because there are so many requirements that it is out of scope that maybe it is not possible to test. So at that time, we have to stand up and say that this is not verifiable requirement. So change it or make the business development or business and development aware that you are putting the requirement but it is not verifiable. So you are taking a risk. So that's why we have to be involved from defining when the user requirements are getting defined. And the end is when validation is complete, when it is deployed, and it is perfectly up and running in the production or in the market after design transfer. And post-validation role, even after it is launched in the production or market, when complaints are filed or any medical device report are filed, generally validation team is getting affected first. They are contacted first. That when you did validation, did you find any defect? So even the post-validation role is also there. Once you do validation, it's not like, oh, I'm relaxed, I have done validation. It's not like that. You have to have a time-to-time connection with customer support or production guys if they are using that system. So this is a verification and validation strategy, which is a potential interview question. That what is the difference of verification and validation? Generally, in clinic validation, first validation comes and then verification comes. Then you do a verification of the validated method. In CSP, first verification comes and then validation comes. So when developers are developing the code, generally they use Scrum methodology, Agile. Has anybody know? Is aware? Yeah. So generally it's management of development. So code is not like developed all at once. They have phases of developing a code. So once one phase is complete, or one unit is complete, developed, they test that unit. So that is called Sprint, Scrum, or Agile methodology. So these are the terms which developers use, and that's a project management for them. So when they develop that, they do a verification of that unit. That is called verification. And when the entire system is developed, you do a validation against user requirements. That is called validation. So this is the main difference of verification and validation. For example of verification is Scrum methodology and Sprint. An example of validation is our traditional documents, validation plan, IQ, OQ, and PQ. I'll go over the practical processes. If you start working in a company, what do you have to do? What are the processes? What are the meetings you will be facing? So generally there are 10 to 12 processes which being held from the user requirement to deployment. First is quality policy. The quality policy has to be defined, and generally all the companies have that if it's established company. SOPs, templates of validation plan, everything is there when you join a company. You just have to follow those templates. If not, then you have to ask, give me the template of validation plan. You don't have to define from scratch, generally. Second is software development. As I said, user requirement is defined first, and software is being developed. And I have written the responsible person or the persons or departments involved in each process. So you know that to whom you have to work with. Quality policy generally, it's a QA's responsibility. Software development, who are responsible, who are involved. Software development team, business unit, because they are the one who defines the user requirement. They know what markets want. Validation team and verification team. Verification team involves development, testers, and validation. Everybody. Then once development is done, risk assessment. That's the important part. Your validation is based on risk assessment. You don't have to go and stretch each and every requirement. You have to first define the risk, which are the risky requirements, where is the risk, which code is highly complex, which code is impacting the final result. And for risk assessment, generally developers, testers, validation team, QA, business unit, everybody is involved. After development is done, you have a meeting of risk assessment. Everybody sit together and define a risk. What is the risk? What worse it can go? What are the patient risk? What are the technical impact? What is the quality risk? It's not only patient risk. There is a quality risk also, that maybe patient is not affected, but the quality of the software is getting poor. So it will affect business unit. That my software is not getting sold. If it's a patient risk, then quality people will get affected. That I have received a warning letter or CAPA or complaint. So risk is defined on the basis of everything. Next is validation. So on the basis of risk evaluated and risk control defined, you start your validation. So define your validation strategy based on risk assessed. Develop your validation plan, IQ, execute on different systems. There are so many operating systems in the market. Macintosh, Windows 7, 8, 32-bit system, 64-bit system. So you have to know that your software is compatible with what operating system. So if it's compatible with all the operating system, then you have to test your installation on all OS. Then you develop your OQ, PQ. You test all your user requirements, functional requirements. You have to develop a traceability matrix. Whenever audit comes, the first thing they'll ask is validation plan and traceability matrix for any software upgrade or for any new version of the software. So for each user requirement, what is the test case? So you have to define that traceability matrix after you develop your PQ. Then generally when you execute PQ, you find defects. In clinical validation, it's called deviation. In CSV, it's called defects or issues or bugs. So I'm comparing this with clinical validation because professor is here. I have to. So the defects are generally there are not major defects because risk assessment is already done, verification is already done. So when it comes to validation, you should expect minimum bugs to be found. Then sometimes if it's a customized software and if it's very complex, then you have to develop some methods that can test those permutation and combination of the software. Because some complex software are not that easy that you click this and this should happen. I mean, there are so many combinations that there are different shades or there are different materials that you can attach with one product. So you have to check each and every combination and permutation. So for that, you can develop some test methods to check everything, or you can use automated tools like HP Quality Center, QTB. I'll get to that. There are so many technologies which is being used to validate computer systems. Then you take screenshots as a PQ evidence. When you execute PQ, you need to have evidence that this requirement has been passed. So you generally take screenshots, and what we do is you just copy and paste all the screenshots in one document, Word document, and attach it with the validation report. Then develop a validation report, and if there is any deviation, you have to create.
I just have a quick question on screenshots. There's been a lot of discussions about screenshots, how necessary they are, or there's some people that don't accept without screenshots that you actually executed the script. What do you see out there? In some cases, it's difficult on some screens to get a shot. They'll have to put a camera up. If there's no print screen function, for instance, you'll have to put a camera up and take a picture. So some people don't want to do that. And hey, there's nothing wrong with documenting. Yes, I did this. Yes, I did this. What do you see out there? Are people accepting that, or is there more insistence on screenshots?
Generally, if you have a physical evidence for any requirement, there are a bunch of requirements which is getting to a final product, right? So if you have a final product, then you don't have to have a screenshot for those requirement bunch, because as a result of that testing, you have a final product.
It couldn't have happened unless you did this.
Yeah. So for those requirements, it's valid. But there are some requirements like installation. Installation is done, but you need a screenshot that the right version has been installed, installation successful, and how much time it took to install. So for those critical user requirements, you should take a screenshot, but not for each and every requirement, because computer system can have like hundreds of user requirements. So depending on software, which one you are validating, you should divide your user requirements. If bunch of user requirements is getting into one final product, then your final product itself is evidence that all the requirements are passing, then only you can have that product. And generally you save those products as a PQ evidence, at least for 7 years. So you don't have to save the screenshots. When you find a defect or issue, first you have to report the issue. There are so many softwares which are being used to report, track, resolve, and to report and track the issues and defects found in validation. You have to define the severity of issues which are found in execution of validation. So these are example of issue handling system, Jira, Bugzilla. These are the software which is being used for issue reporting. So generally, you are executing a PQ, you found that this requirement is not matching, you have to create a bug in those softwares. Developers are getting assigned that this is a bug found. Generally at the end of the week, the meeting is held and everybody decides that what is the severity and risk of these bugs found, and decision is taken that these bugs have to be fixed in this version or next version, or if we can live with it. So those discussions happen, and we have to justify that the bug is found, the defect is there, but it is not risking the patient safety or quality of the system. It's just annoyance. What is the level of those bug or defects found? So if it's a minor bug, then we can live with it and we can fix it in next version or whenever is the upgrade is coming out or in the patch of that software. Then generally after you complete your validation, if a major deviation is found, you do a root cause analysis. What is the cause of the bugs found? Generally developers and validation teams are involved in that. And if an issue is found after your launch of the system, corrective and preventive action has generally CAPA document created, and you have to define a corrective and prevention action of that defect or issue or complaint which is being filed by customer or by the user. Complaint handling. You have to consider complaints when you define a strategy, because you define a strategy on the basis of user requirement, but when a user actually uses that system, maybe they can have we can miss some scenarios. If it's a complex system, we can miss some scenarios, and complaints are getting filed with the customer support or with medical device reporting. Then we have to take in consideration when we validate the next version that those complaints are filed. They are not repeating again. They are fixed. So generally, those complaints are getting into consideration. And gap analysis. These are not the last four: complaint handling, gap analysis, root cause analysis, and CAPA. These are not a normal process. But if a process didn't go well, then you have to do a gap analysis. That what went wrong and what we should do to improve the process of validation or starting from the development. So these four processes are, if necessary, if applicable, then completely. And then final system maintenance and retirement, which is the last phase of the SDLC process. That after system is launched, there are some defects which we decided at the development that we will leave with it. Then business unit decided that okay, we will upgrade the system, and these are the bugs which will be fixed. And generally they do some code changes and fix those bugs. So these are upgrades. Whatever you get, if you're using iPhone, iOS 6, iOS 5 came, then iOS 5.01. So in those 5.01, they fix some bugs. So it's the same cycle which goes into medical device software or software which are being used in production also. They keep fixing some bugs which they left in the first version, and that's called a maintenance of the software. So the deliverables of CSV. What are the documents you are looking at when you complete your validation? Plan, IQ, OQ, PQ, traceability metrics, risk assessment, test reports. If you have developed methods to test software, then you have to develop test reports. User cases. Generally, PQ involves worst, medium, and best user cases that run the system with highest number of users, load test, smoke test. So those kind of worst cases, they are called user cases. Disaster recovery plan. If software gets corrupted or Sandy came, everything lost, what do you do? So generally they have a backup every day of the system data. So if it's a brand new system being developed in-house, first along with the user requirement, disaster recovery plan has to be in place. So before development, when they start development, even the code should be getting backed up. So if anything, because it's an electronic system, anything goes wrong, fire, anything, computer got lost, earthquake, anything, but data should be saved. So after this 9/11, people are more focused on disaster recovery plan. So that is being developed if it's a brand new software being developed. Validation report, deviation form, and for some jobs you might be asked to develop SOPs also if they are not defined. if it's a new system. If you are joining a brand new project, then you will have to develop SOPs. Or if during the process you find that this SOP needs a redlining or needs update, then you will have to update the SOPs too. Question? So this all conversation was about customized software, when the software is being developed according to the user requirements defined. And for the commercial off the shelf softwares which we buy from the supplier or vendor, that mostly vendor assessment and those documents they deliver. If required, we do a validation again, IQ, OQ, PQ, traceability metrics, same. We get user manual instruction for use, how to use the software from vendor, and requirements and specification that also we get from the vendor. So what do you think after this conversation, that what is the main challenge to get into the CSV job?
Knowing the hardware specifications for description languages like Verilog.
I think so many people think I don't have a software background, so I should not go to CSV. But I'm a validation expert. So you know what you are validating. You know why we are validating. You know the user requirements. So it's not a challenge. If you don't have a computer system background, honestly, when I was in India, till 8th, I have not touched computer. So, I mean, if you have a basic knowledge of computer, it is very easy to work with computer systems. And once you have experience, you will know what are the basics, what is code, what are the languages, how does code get affected. So it comes with experience, so it's not that difficult to get in CSV. And the main thing, the reason of our job is FDA, because FDA is putting the regulation. If they are not putting regulation, our job is not there. And the solution is there in FDA. They are telling us what to do. So you don't have to worry that, oh, I don't know what to do. Go to FDA site, that this is the Bible for me, FDA site, fda.gov. They have everything written, what you should do, what test you should perform, how the risk assessment should be done, when you should do verification, when you should do validation, what are the documents they will seek when they come for the audit. So I don't see there is any challenge, at least for validation. Whatever you want to know, go to fda.gov, type in search box. You will have at least some guidance how to do that. And here, if you are talking about the challenges, I want to share one of my experience, which I had a challenge at my work, that I was validating a very complex customized software which has hundreds of combination and permutation. So if you just focus on user requirement, it was not possible. User requirement will say that, okay, this it should be able to scan, but it should be able to scan how many products? Hundreds of products. So I cannot go and to each and every product and scan and then, okay, now this user requirement is passing. It can scan every product. So first version we validated, it was launched, and customer had so many complaints that we have this, we cannot do this shade is not coming up, there is a mismatch, there is an error. So after that, we decided that if it is not possible to check each and everything in executing the PQ, we should do ad hoc testing. So when we get the software from the developer, sit and just play with the software, ad hoc, without any documentation. Try to do all the combination and permutation, because validation requires too much documentation. So 50% time goes in developing documents, 50% in execution. So if you really, if you sit and try to create a user case for each and every combination, it's just impossible. And in industries, you are given a deadline. In 1 month, I need a software to be validated. So, I mean, for me, it was not possible to do each and everything in 1 month. So that's why I have to ask with management that I need 1 week extra, and asking for 1 week extra is a challenge to management. They will not give you. They have a set launch date, and you need to give a strong justification that why I need 1 week more for validation. So somehow I convinced them, and they gave me 1 week more, and I used 3 or 4 weeks of validation into ad hoc testing, squeezed my validation, and but the results were good. There were less bug or defects found when it was launched, because during the ad hoc testing we found most of the bugs. Sometimes it's called a dry run in the industry, that before you actually start execution and writing a valid script, in the valid script you actually do a dry run. So if you have a deviation, it will fixed. It will not. You don't have to perform that lengthy process, create deviation and then close it, create kappa, close it, get approvals from QA, get approvals from business unit. So you will avoid those lengthy process if you do a dry run. So I think in process and equipment validation is called a dry run. So I just try to implement the same strategy in CSV, ad hoc testing. Just try to play with the software, do whatever combinations you can do, and find out the bugs before. That's what we call it, do right for the first time. So, and get the defects ahead of the time, not the later in the process. So these kind of challenges you will have when you actually work, but if you know the basic principles and why you are doing that, you will automatically have those ideas that how should I improve the process, or how should it be more effective and efficient. So it's not that difficult. To get into CSV, the basic knowledge, hardware, software. I think you wanted to know that, right? Hardware, and yeah. The basic knowledge you should have is what's the difference of hardware, software, registry keys, different operating system, different graphic cards of the basic structure of the computer. What are the graphic cards? Because when you install a software, if there is another application, for example, Skype is installed in that system, that can affect the software you are validating. So you never know from where the defect is coming, why this is an error. In a same software in a different system can work fine. So you need to know the basic the basic knowledge of computer, how the software gets installed or registered, different OS, different graphic cards, different network, LAN, WAN, ERPs, enterprise resource planning systems, the SAP's ERP. Then installers are generally in .exe files. For Mac, it's .dng file. Then how to uninstall the software, go to control panel and uninstall. Then system and computer configurations, how you change the configuration adapter settings. These are the basic knowledge of computer. Encryption and decryption of the files. Generally, when the file is encrypted, it's a format .dat, .dll. So these are encrypted file. The user cannot open that file unless you have a decryption software. And the code, who is developing a code, that developer only knows how to decrypt that. So only they can decrypt the file. That's why we buy so many software, but we don't know where it is getting installed, where is its registry key, how to decrypt it. So that is a user requirement, that user should not decrypt, cannot decrypt the software or the file. And the overall architecture of the system, there are some instances that it is not only one software. There are multiple software linked, there are interfaces, and you have to validate the entire system. That can be also possible. So first you have to know the infrastructure, architecture of the entire system. First system, what is the middleware or interface? how it is connected to the second system, what is the middleware. So generally that infrastructure is coming from the developer, and you know how if there is an error coming in first system, you know that this is a code problem. If the error coming is in second system, there might be effect in the interface, there might be effect in the first system, there might be effect in the second system itself. So if you don't know the infrastructure, it would be very difficult to know that why this error is coming. And this is my personal suggestion: if you really want to go to CSV, or if you get a job in CSV, there is a good certification, Microsoft certification, installing and configuration Windows 7 client. This is a basic certification which gives you I think it's only three days of courses, online course, costing about 1,300. But if you're working and the company is paying for your training, take their benefit. So yeah, if you have like 6-7 months of experience in CSV, then it would be great to take this certification. You know how the system can be configured. And most of the users will use Windows 7. There are some users using Macintosh, iMac and MacBook, but 90% would be Windows. If still question, Google it. There are some best practices you have to follow when you are working in a CSV. Always when you define a validation plan, always define what is in scope, what is out of the scope. There are some requirements which you have already defined when at the start of the development, that I cannot test this requirement. Put it in out of scope. So when audit comes, it's not on you. Why you have not put that in out of scope? So when you're creating a validation plan, there are some best practices that you should follow. Always update the revision history of the plan. If the software is getting upgraded, generally the first version is getting obsolete. Second version. So in second version, you always update the revision history. What is being upgraded? What has been updated in the second version? Always save the hard copy of signatures. These are best practices from my experience. What I have learned in 4 years. I was like, I was not that confident or knowledgeable when I started job before 4 years. But this is I have learned in this 4 years, that always save the hard copy of approver, whoever approving your document. Because if something wrong in electronic system, and if you lost signatures, then if audit comes, then you are gone. There is no signatures of the documents. And always put those signatures in a fireproof cabinet. So if fire happens in the building, you are safe. Always be proactive rather than finding issue at the end. If you know that this is something wrong, always talk to the developer or business unit or QA or risk assessment that I think that there might be an issue here. So be proactive and find the issues in the beginning rather than later. Always perform a dry run before you execute. Follow the template established by QA.
What does that mean? You didn't follow it one time?
No, I follow it. No, actually, when I was studying, I thought that whenever you have a job, you have to create a template by yourself. So I thought maybe these people might be thinking like that. So let me clear it. It's not like that. The templates are defined for every company. Validation procedure, how should it be carried out, that is also defined. So once you have a job, you go to this job, you have to ask, give me the SOP, validation, give me the validation policy. They generally give you, but if they doubt that, if they want to check you, they will say you that, okay, develop a validation plan. And if you don't ask that, give me the template, they will know that you don't have basic knowledge. So you have to ask, give me the template, give me the policy.